Good morning, everyone. Apologies for being a little late here today. We had some technical difficulties. Today, I am joined by, well, excuse me, actually, let me introduce myself. My name is Christy Hayek. I am the Director of Public Affairs for SCANPH, and I want to introduce David Avina from AEA and Ian Sharples from CHP, who are going to be kicking it off, as well as Ari Usher. Sorry, Ari, from AEA as well. If you guys want to go ahead and just say hello and introduce yourselves as well, feel free.
Yeah, like Christy mentioned, my name is Ian Sharples. I'm a sustainability program manager here at the California Housing Partnership. Also joined by my colleagues Ari and David from AEA. We all work on the BUILD program together. It's the Building Initiative for Low Emissions Development Program. Let you know a little bit about this program, then explain our agenda for the day. So if you want to go to the next slide, David. Some introductions. We've already kind of established that, but yeah, David's a program manager and Ari's a project manager for AEA. But the build program is really intended as kind of a market transformation program for all electric new construction. It's really intended to bridge the electric ready present to the all electric future. We're all expecting, changing codes, changing decarbonization mandates, and really just expecting, clean energy technologies to be the way of the future. And so this program is intended to help incentivize that and make sure that those technologies are accessible to low-income Californians and affordable housing developments. Next slide. Uh, what Build can offer is primarily two things. The first is free technical assistance, and this will be available for the life of the program, regardless of financial incentive availability. So this gives you 300 hours of no-cost technical assistance to help build your in-house capacity for all-electric new construction. It's a free resource available for you. If you're new to all-electric design, definitely put in an application. It'll be able to help you out a good bit. But what Build is really kind of known for is the incentives. That's the up to $2 million in financial incentives for all electric new construction, as well as a special new adopter design award for up to $100,000 to help defray some of the direct costs in designing first all electric development. It's really encouraged to layer this program with other funding sources, other programs. And finally, in terms of the financial benefits, you get a long-term reduction in utility costs and the elimination of gas infrastructure costs. And that's something that the TA team can really help you with is kind of eliminating those long-term costs. So next slide. Some of the things that Build's TA team can help you with are, pretty much any design problem you have that you're coming across. The earlier you get in, the better. But some things would be, design best practices, project design review, local permitting, operations and maintenance training, post-occupancy system support. They can help with incentive layering, so getting built to work with other programs, and just general kind of assistance application. So, with that, I'd like to go over today's agenda. First, we're going to be setting the stage with some policy trends. That'll be David discussing that. Then we'll look at what are the technologies behind all electric design. So, understanding energy support storage systems, electric vehicle supply equipment, heat pump clothes dryers, induction cooktops. And then finally, we'll wrap it out with a discussion of different whole home standards that are kind of making the news today and encouraging folks to move to more all electric designs for a number of different reasons. So we'll discuss a little bit of that. So I think with that, we can hand it off to David. So take it away.
Yeah, thanks, Ian. I'll actually be starting us off. Hi, everybody. I'm Ari. Really excited to be chatting with you today. Hopefully, the build program may not be totally new for all of you, but just a good reminder that, we're still here. There is still significant funding in the Southern California region. So, yeah, I'm going to talk a little bit about some policy trends and setting the stage. Let's go to the next slide. Yeah, so we'll start with a bit of context for all electric housing. Building electrification is not just about climate. We consider a bunch of different benefits. First of all, safety. By removing combustion appliances from our homes, we're actually eliminating the primary source of carbon monoxide and also nitrous oxide. And no more gas piping in our buildings means that we're also eliminating the source of potential gas leaks. Gas explosions are no joke. Thankfully they're not super common, but no gas piping to the buildings means we're just that much safer. There's also health benefits. Gas cooking in particular is linked to respiratory illness, especially in children. This is really about the combustion of food that's related to gas cooking. When we do talk about some of our technologies, you'll hear a little bit more from David about some more of the benefits of removing gas cooking from the home. And of course, we do have climate benefits. When we pair all electric end uses with clean electric generation, we are actually really significantly reducing greenhouse gas emissions versus gas. And building electrification is a relatively low-hanging climate strategy. So that's why there's quite a big push. And then resilience. So all modern gas equipment uses electricity. In the case of a power outage, it's not necessarily the case that your gas equipment will be able to be used, as all modern gas equipment does use electricity. And electricity is typically restored faster than gas in disaster-related outages as well. And also cost. All electric buildings are in the new construction side are usually cheaper to build and operate. Some electric upgrades, may be slightly more expensive, but you are really saving on gas main extensions, connections, meters, and piping, as well as combustion safety testing. So let's take a look at some more drivers of electrification. I'm just going to talk briefly about 2025 Building Energy Efficiency Standards, also known as Energy Code or Title 24, Part 6. The proposed 2025 Energy Code does go into effect as of January 1st of 2026. So it is coming up. And this code cycle really builds on some of the forward-thinking electrification measures that were first introduced in 2022 code. So we are seeing further encouragement of heat pump technology. The heat pump baseline has been expanded for multifamily housing. Most of our space and water heating are on a heat pump baseline, with a few exceptions. Also increasing electric ready requirements. So in addition to the electric ready requirements that went into play last code cycle, it's been expanded now to include central heat pump water heating as well. So we've actually got electric ready requirements for cooktops. We've got electric ready requirements for dryers. We've got them for furnaces, unitary water heaters, and now expanded to central water heaters as well. So, there's also new requirements around space and ventilation provisions for future heat pump water heaters. And with so many electric ready requirements, installing electric equipment to start out may be easier and cheaper to do given these additional requirements. So this is really how the Energy Code is pushing us towards all electric without making it entirely mandatory. PV and battery storage standards, we've already got prescriptive PV requirements on almost every building type, single family and multifamily, low rise and high rise, and many of our commercial building types as well. We've got battery storage requirement on multifamily buildings above 3 stories. And there are battery ready requirements for single family as well. And then finally, strengthening ventilation standards. Energy Code also looks at energy efficiency. So some of the big changes for 2025 is we do see mandatory balanced ventilation for new dwelling units. And we also see mandatory air sealing and air leakage testing for new dwelling units. So those are some big changes. And I saw a question about AB 130. I can talk about that briefly. So AB 130 was passed earlier this year. It does freeze residential building standards as of October. It freezes it until 2031. But the 2025 standards were approved before that date. So 2025 is going to go into play. And then 2025 will be the residential building standard that we will freeze at. We'll basically skip the next standard 3 years later in 2028 for residential units. And then we'll be essentially working towards the next standard in 2031. So that's AB 130. You know, there are a number of executive orders and bills kind of coming out. Another one that we maybe should mention is for wildfire rebuild. There's an executive order that allows the 2022 standard to be used there. So some reduced stringency. Additionally, PV and battery requirements are going to also be exempted for those wildfire rebuilds. So there are some exceptions to this, given just kind of the state of California at this time. Great. So I think that's everything. Let's go on to the next slide. Thank you for that question. It's very helpful. Just a little reminder of our California climate policies and targets. So starting over at the end, you know, 2045, this is kind of the goal of 100% zero carbon electricity and statewide carbon neutrality done equitably. The state is really working very hard on this, especially the equitable side of things. So a couple of the kind of milestones that are going to help us get there is by 2035, we're looking at most likely the phase out of new gas powered vehicles being sold in California. And then 2030, that's really our 50% renewable electricity goal with energy code doubling energy efficiency and 6 million heat pumps installed as the goal. Yeah, so next slide, please. Yeah, and when we think about the all-electric future, you know, in many cases, the all-electric future is already here. Many jurisdictions, you know, are considering policies that favor all-electric buildings or may already have passed those policies. Title 24, as we kind of just went over, the 2025 code cycle will heavily favor all-electric. And then future code cycles, while we do get a brief pause, will continue on towards that march and may in fact be 100% all electric. And for anyone who works significantly on retrofit as well, there's some talk of retrofit codes also including electrification measures going forward. You know, so right now there's quite a bit of incentive funding around building mixed fuel with gas infrastructure, you know, at this point risks becoming a stranded asset. It is possible that going down the line, you won't even be able to purchase gas appliances in California anymore. So it is really worth thinking about your electrification and building all electric right now. As building electrification accelerates, there, you know, fewer and fewer gas customers will share the burden of increasing gas rates. So with that, let's dive into some of your options for all electric technologies, and I will pass it over to my colleague, David.
All right, thank you, everybody. Let's get into it. So first, we'll start with the biggie, energy storage systems or battery systems, however you want to call them. But typically in the industry, it's battery energy storage systems or energy storage systems. So there are many benefits to energy storage systems. Many storage systems themselves have energy management systems that allow your battery to respond to fluctuating supply and demand of electricity. So batteries can also be leveraged during high peak grid demand to reduce your electricity costs, and also combined with solar photovoltaics, so solar panels. Energy storage systems can also extend the benefits of solar. So to store the energy that's generated by the solar PV, and you can then leverage that while the solar PV is not generating, likely at night. Energy storage systems can also provide backup electricity during power outages, right? And in addition to the fact that in power outages, electricity is usually the first utility to come back in line, it could also kind of extend that resilience and improve that resilience in your home and your property. There is a baseline credit in Title 24 for battery systems in high rises, so there's those things to consider. Other considerations are also that battery storage systems must comply with rigorous fire codes. that could impact or limit the locations where you install these systems. So our TA team can help support and review your storage system designs to make sure that one, they're fire code safe and fire code ready, but also that they're optimized and as efficient as possible. Biggest positive on the build program is that we do provide a kicker for the energy storage system that you install in your properties. So this kicker would be an incentive amount of $250,000 or $250, not 50,000, $250. Sorry. Um, per kilowatt hour storage capacity. So, if you're looking at somewhere around 17 kilowatt hour of energy storage capacity, it's about $4,000, for that specific equipment. So, it's a really good kicker on top of the base incentive that Ian had talked about earlier in the webinar. And so you have this base incentive. You may also have a new adopter award. Then you have this kicker. On top of that, you could then also layer other opportunities on top of the build program, right? So there's SGIP, SOMA, and also SMUD had some incentives associated with battery energy storage systems. I would always recommend check out the switches on. They have a culmination of many different incentive programs across the state. So if you have any questions or want to have a one-stop shop to identify what programs or can my equipment be incentivized by, check out that place or even come to us at Build and we could help find the best layerable opportunities for you depending on your property and depending on the equipment and design. All right. Next piece of equipment we'll talk about is EVSE, also known as electric vehicle supply equipment. So these are your charging stations, right? These are your chargers, EV chargers. There are current state and local requirements for EV charging availability, and there's also more incentives than ever for EVSE, right? So for new construction, consider sizing electrical service and infrastructure for potential EVSE in the future to reduce service upgrades costs down the road, right? So you want to build and be EVSE ready while you're doing the construction now, so that way you don't have to add it on in the future. Maybe you have to redesign a couple panels and increase the size of the electrical service panel. So you want to be ready, if not already install them as the property is ready to lease up. EVSE does provide convenient access to low-cost at-home electric vehicle charging. So especially for a lot of disadvantaged communities that don't have many local electric vehicle chargers for their plug-in hybrid or all-electric vehicle, having an EVSE charging station at their property comes with a big benefit and also supports EV adoption while eliminating tailpipe emission and improving outdoor air quality and really transitioning disadvantaged communities, low income and moderate income communities over to a zero emission future. So EVSE is a critical piece to the electric vehicle transition. There are several types of electrical vehicle charging systems. So typically what you see is these three different levels: AC level 1, AC level 2, and then DC fast charge. These do come in different sizes and voltages and amperage and plug types, so it can be very confusing, especially for the user. But this is a pretty simple breakdown, right? If you look at your app, if you have a plug-in hybrid or just an electric vehicle charger, typically the standard for a slower charger is this J1772. These are lower voltage, generally compared to the DC fast chargers. And they also have a different type of plug, lower amperage as well. So, depending on what you're going to be installing into your home, into your property, you want to consider these different levels and consider what my tenants may need. Other considerations are also charging load and charge time, right? So when you're looking at the AC level 1, this is basically your 120 volt. I could plug in my car into my outlet on the wall, and that's how I charge my car, right? I have a plug-in hybrid, about 42 miles on the battery. And on an AC level 1 charger, it typically takes me 2.5 hours to charge from 0 to 100%, right? So quite a bit. Looking at AC level 2, about a 240-volt charger, that's a little quicker, right? You're now looking at cutting the time in half. You're now looking at quicker charging time. DC fast chargers, depending on the vehicle, you could go even further, add even more miles to your vehicle, right? There are amperage considerations associated with each type of chargers. There is also voltage. So, looking at plug type, looking at electric panel type and size. So all these are different considerations that you should consider when you're going to be installing EVSE equipment. Typically, what you're going to see in most properties and most even garages or you know just more multifamily buildings is this AC level 2. Uh, there's a most middle ground and lowest hanging fruit for EVSE. Uh, there are also, of course, various types of AC level 2 chargers, and Build can provide kickers for these different types of AC level 2. So we're going to move forward and just talk about this 240 volt, approximately 80 amps, 10 to 20 miles per range per hour. So that's going to be what we're going to be moving forward and talking about. So when you're considering EVSE in multifamily residential housing, load management is going to be crucial because it can allow installation of more charging capacity than the building has electrical service, right? So when you have load management systems, these allow power to vary to each charger based on the needs of the EV and the number of EVs plugged in. The EVSC load management capabilities allow you to connect multiple charging stations to a single circuit, which helps you avoid installation costs or upgrades and even further upgrades in the future, right? So take a look at this chart of how, the electricity is moving from the grid to the building, into the charging stations to the vehicle, or directly from the grid to the charging station to the vehicle, right? So typically what you see is fewer vehicles equals more power per vehicle, or if you have a lot of vehicles, then that's distributed across all of the vehicles, all the fleet that's connected into these charging systems. The next type of EVSE is bidirectional. So just as the name implies, the electricity can go in both directions, right? So this creates a more complex version of load management. So as the name alludes, of course, bidirectional EVSEs converts your EV into a distributed energy resource, similar to your battery energy storage system, right? It can also power energy storage systems, so it could create a backup power to your backup power, essentially. And it could also power other equipment like plugs and appliances, as well as other electric vehicles. So bidirectional charging unlocks resiliency benefits of EV batteries. From your transportation, it unlocks resiliency benefits into your property and offers demand response capabilities and can further decarbonize your backup power, right? Again, almost expanding the capacity of your energy storage system by the number of EV vehicles plugged into these charging stations that are also plugged into the grid and plugged into your property. Next is smart EVSE, right? Because everything has to be smart nowadays. Smart EVSE takes load management even further by not only considering on-site load and demand, but also electricity rates, greenhouse gas signals, and other dynamic grid signals. So these chargers are even more dynamic and provide even more support to your fleet, to your electrical service by throttling your demand and response specifically to the vehicle, depending on what it needs and depending on the rates and time of use, right? So you have these different layers, these 3 different layers of EVSE technology, and these 3 different layers come with 3 different kicker types, right? And as you can imagine, that as it gets more complex, as the technology gets more complex, it gets more expensive, right? And so that's why we have proportionally allotted different kicker standards for each type of technology, right? Regular EVSE, you're looking at around $200 per charging station for a single family home. If you're looking for charging stations for multifamily homes, you're looking at $300. Bidirectional is a single incentive amount for multifamily and single family, so that's $1,000 per bidirectional EVSE. And for the smart EVSE, you're looking at, again, that division between single family home and multifamily at $500 and $600 respectively. Also, there are many different EV charging programs out there, right? Between Edison and Communities in Charge, I would also recommend checking out the Switches On again for this type of technology. But there are many programs that come and go that you can leverage on top of Build and layer on top of Build to install these type of equipment into your home and help again transition not only the community but the state into a zero emission roads and cleaner air on the streets. Okay, lots of EVSC. Now let's go into the home. Now we're talking about laundry, heat pump clothes dryers, right? So for electric laundry, we're mostly talking about your dryer, right? For in-unit specifically, you have several options, including heat pumps, electric resistance, and a combo washer dryer with condensing or heat pump units installed. The heat pump units will be more efficient, though they are a little bit slower to actually dry. And from a design standpoint, they do have lower amperage requirements, right? So when you're looking at the electrical panel service, there's design considerations associated with that. Electric resistant is faster, but it is large. It is a larger energy user, right? And it still needs a vent. So again, design considerations and placement considerations associated with that. The combo washer dryer probably has the longest cycle, given that the unit does wash and dry in the same one appliance. And drying does take longer because these equipments are ventless and have a smaller capacity typically because it's just a combo, right? Generally across the board, there's additional benefits that they're easy to install. There's no restrictions or minimal restrictions on location installation. They reduce electricity use by 28% when compared to standard clothes dryers, so the gas-powered clothes dryers. They're gentler on clothes because of the lower heating temperatures that it could provide, and also have a longer lifespan than standard clothes dryers. So you're looking at 20 years versus the 13 years typically for a standard gas dryer. When it comes to commercial, really your only option is electric resistance dryers. And when you pair these with high efficiency washers, they can have a less overall runtime between both appliances because the functionality of the washer improve, I guess, the water removing function. And so it removes more water from your clothes, allowing it to dry even quicker, right? So it's just high efficiency on both ends from the washer and the dryer. So that's for commercial. But really, when we're talking about kickers on the build program, we do only have kickers for the heat pump clothes dryers, and that's going to be about $150 per heat pump clothes dryer unit. All right, induction cooktop, right? Electric cooking. Now we're coming into the kitchen. So when it comes to electric cooking, there are three types of cooking services with different performances and functions. All of these do have electric ovens, and I think the biggest factor in the electric oven is the convection piece because convection is typically preferred for bakers. I would say so myself. I like to bake. Most commonly, when people think about electric cooking, they think of the electric resistance with the coils that are one, hard to control and also have limited temperature ranges. They also typically burn things easily and stay hot for a while after they're turned off. So that's why we want to educate more folks about both radiant and induction cooktops because one, they look similar to each other, but they are of course very different. Radiant radiant cooktops have coils that heat the surface similar to the electric resistance coils that I just talked about. And they're still using radiant heat, right? They're still using the heat from the cooktop to heat the pan, to heat your food and cook it. But really the gold standard of electric cooking is induction. And I can talk to you about why in the next couple of slides here. So induction cooking uses electric currents to directly heat pots and pans through magnetic induction. Instead of using thermal conduction as gas or electric elements use transferring heat from the burner to a pot or pan, induction actually heats the cooking vessel, so heats the pot or pan itself almost instantaneously. The same process is used for charging your phone with a wireless charger. Um, so it's quicker and more direct. So what does this mean for functionality, as an end user, right? You do have a faster response time. So to cook or boil water, it's extremely quick, right? It can typically boil water in about half the time compared to gas. It is incredibly precise as well. You could dial in specifically the temperature that you need. So those that are bakers and, maybe are tempering some chocolate, it's incredibly important to have that precise heating control. And induction can provide you that versus gas powered cooktops that you're kind of playing a guessing game, right? And the fact that the cooking element does heat up the vessel, so the pot or pan directly, means that there's no heat waste, right? So it's only heating the pan, it's only heating your food, it's not heating your kitchen. And it's produces less of that heat waste. And there's also no open flames, right? Only the pan gets hot and the actual cooking surface, it gets warm to the touch, but definitely not scalding, third-degree burns hot, right? So it is safer. It's safer for kids. It's safer for anybody in the home. And above all, just kind of to circle it back, it does also have health benefits by the fact that there's no open flame. You don't have any of those carcinogens or benzene or methanes coming into your home that needs to be exhausted uh, through the exhaust vent on top of your stove. So there is, a health benefit associated with cooking with induction versus cooking with gas, right? Okay. Also, there are other considerations, especially for the end user when you're looking at induction cooktops. Currently, cooktops are not the induction cooktops are not the cheapest, although prices continue to come down as the market continues to shift. There are also incentives to help reduce these costs, like build, and there are different options depending on what you're looking for and depending on the price range. You do also need to consider compatible cookware. So depending on the property, depending on your tenants, you may want to consider an option to include cookware upon move-in, or have folks test their cookware with magnets from their fridge, and then replace whatever cooktops or stoves, pans, pots and pans that they need to replace if they're going to be using the induction cooktops. Kickers. So there are kickers associated with induction cooktops. They're looking at about $300 per induction cooktop. And again, I would recommend going to the Switches On, going to other websites associated to that, because there are many other incentive programs, not just Build, to emphasize and encourage the use and adoption of induction cooking. And I want to emphasize once again, this is a kicker, right? You do have a base incentive for Build. You also have potentially a new adopter award, and then a kicker on top of that specifically for this equipment. So there are a bunch of different opportunities, a bunch of different types of technologies beyond heat pumps where you can electrify your home, right? And it's not just electric resistance. For the most part, you do have other heat pump capable technologies and equipments associated with appliances in your home. All right, switching gears, now talking about the whole home, I'll pass it back to Ari to talk about a couple more standards and practice that our Build TA team can support you with.
Thanks, David. Yeah, let's think a little bit about the whole home here and energy efficiency in addition to electrification. I know we really focus on all electric technologies, but it's important to remember that energy efficiency is just as important in our building decarbonization as electrification. Give me 1 second here. I was in the middle of answering one of the questions in the chat. Let me just get back to my notes. Apologies. So yeah, I would like to talk about passive house standard. So passive house is a standard that is internationally recognized. It's actually the only internationally recognized energy performance standard in construction today. And we do have a couple of passive house professionals on staff here at AEA. So if you are interested in looking at the passive house standard, or even just incorporated some passive building design elements into your construction, we can help you through TA. We'd be more than happy to assist. Yeah, again, the passive house standard is kind of a in-depth process to get passive house certified. It's probably similar if anyone's familiar with getting LEED certified. There's requirements to be met, and then you'll receive a certification at the end. But I just do want to reiterate that passive building principles are also important to consider and can actually be incorporated in design without trying to reach that certification. So we're not trying to say you have to be passive house certified here, but let's talk a little bit about what some of these principles are. It's really about minimizing the building energy load through passive design principles. So the first thing is thermal control. Thermal control helps keep the inside warmer when it's cold outside, and also keeps the inside cooler when it's hot outside, maximizing energy efficiency. Passive building does this through incorporating continuous insulation into our envelope and really minimizing thermal bridging. Those are kind of the common energy loss components in our typical envelope. So that's our thermal control. Passive house also looks at air control. Passive buildings achieve air control by air sealing the enclosure, and then by providing balanced mechanical ventilation. So the air sealing is really important. A lot of energy loss in buildings actually comes from a leaky envelope where that air kind of is able to filter out, and it takes with it the conditioning energy there. So air sealing the enclosure is a big part of our air control. And then providing our mechanical ventilation is going to allow superior indoor air quality. Passive house also encourages a heat recovery and energy recovery ventilation to further increase energy efficiency. So bringing in clean outdoor air that is actually tempered by the outgoing indoor air. This really reduces the heating and cooling load that needs to be made up by the mechanical equipment. So that's what air control is. Then solar radiation control. And this is actually done through highly efficient, high performance windows and doors. Passive buildings need to balance the solar radiation through high performance windows as appropriate. And then shading strategies as appropriate as well. So we want to reduce overheating from solar radiation gain in the house. That's that sun coming in through the windows. But we also want to be able to leverage solar radiation depending on climate zones. So sun coming through the windows actually can provide some free heating in the winter in our heating dominant climate zones. So designing to really control that solar radiation specific for the climate zone. And then finally, moisture control becomes an important thing in passive building because our envelopes are so tight. Special attention should be paid to control the moisture in the home to maintain a healthy indoor environment. Looking both at vapor and moisture control in the envelope itself, as well as using mechanical systems like that energy recovery ventilator to help maintain a healthy environment inside. Next slide, please. Yeah, so wanted to kind of share some recent news, with the disaster wildfires that occurred earlier this year in Southern California. There was some reporting around homes that were built to the passive house standard actually withstanding those fires. And, you may have seen some news about a passive house being the only structure left standing in a devastated neighborhood. So there is some kind of evidence that shows that some of these standards in passive house may actually have a benefit towards wildfire resilience as well. The airtight construction and simplistic design of passive house is one of the things that can actually help with this to reduce ember intrusion. So ember intrusion is a major cause of homes igniting during wildfires. Passive house buildings have a robust insulation layer and airtightness threshold that reduces potential entry points for embers. In addition, a simplistic design, that is to say a roof design that doesn't have a lot of peaks and valleys, a home that doesn't have many twists and turns in the envelope can reduce areas for debris buildup, which is another place that embers can alight. So these are some of the things that will reduce ember intrusion. Passive homes also have, that advanced filtration and ventilation system. This is a layer of protection not often found in conventional buildings. And yeah, I'd just like to say, there are, more building strategies around wildfire resilience than just what I've covered here. Passive house isn't necessarily a wildfire resilience intended standard in and of itself, but the airtightness and the simplistic design really do offer that benefit. So if you are looking at wildfire resilience strategies, there's other resources. One is the U.S. Green Building Council. California has out a guide earlier this year for wildfire resilience. So that's a good resource to look into for more information. Let's go to the next slide, please. Yeah, and then just, more on the energy efficiency side of passive house and passive building, there are benefits to energy efficiency, building load, and the grid more generally. These principles will help reduce annual load. They can also actually help with reducing our peak loads and providing a flatter load shape in those passive house design buildings. Offering a more predictable load, a more flexible load as well. So that really does help with kind of those peak load events. This is actually enhanced in inland climate zones where we've got more extreme temperatures, offering greater benefits there than in those coastal climate zones. And particularly, they're relevant for addressing winter loads, which as we switch to electric heat pumps for our heating, we're projected to see an increase in peak winter loads in the broad electrification trends in California. So this becomes more and more important. Passive house design principles will also minimizing that load. The other benefit of that is that it reduces the renewables that are required to meet your building load. So, again, if you're interested in passive building designs or passive house certification, we're here to help. I also wanted to mention that there is some talk. There was a bill introduced into California Congress, which would actually look at using the passive house standard as an alternate pathway to showing your energy code compliance. So if approved, that would mean that the state of California would be looking into passive house standard as an alternate pathway there. Yeah, so lots of interesting things to consider in this environment, both our weather environment and our political environment. And with that, I'm gonna hand it back to Ian to kind of close us out and take questions.
Cool. Thank you, Ari. Let's see. Again, I want to reiterate the build technical assistance services that are available. It's up to 300 hours of no-cost TA, so it's a free resource for you to help build your knowledge throughout the development process of implementing all-electric design and technologies. I think we started a bit late, so I think we'll kind of just skip right to the Q&A. I see a couple of questions about the program itself, so I can answer those real quick. The first one is from Lisa Hart. Is there a reason you're using kicker instead of incentive? In the build program, the kickers are part of the total incentive package. So the incentive package is made up of four components. There is a base incentive that is based on the greenhouse gas emissions avoided. There's an energy efficiency incentive based on how efficient you are above what's mandated by the code. There's a solar PV incentive based again on how much you're installing above code. And then finally, there's the kicker incentives, which are specific dollar amounts for specific technologies that you install. So, for example, if you install a smart thermostat, that'd be like $75, and then you'd multiply that across, however many thermostats you're installing in the development. So hopefully that explains that part. Rachel Marmenstein, I hope I'm pronouncing that right. Is the funding for this program only available in Southern California or also Northern California? Carol Roberts is also asking for an update on the funds for the program. Right now we're at pretty much fully subscribed in PG&E territory, so the funding for this program is split up by investor-owned utility territories. PG&E is pretty much fully subscribed. SDG&E, San Diego Gas and Electric, is getting pretty close, but I think there's about a million, maybe a little bit over a million that is remaining in that territory. Southwest Gas, which is like Barstow and Tahoe, we have $900,000 remaining. And then in the SoCal Gas territory, which is most of Southern California, we have about $12 million remaining. So hopefully it gets subscribed pretty quickly. And if you have anything that you're interested in applying for Build For, definitely apply as soon as possible. The earlier you get in, the better. And yeah, you'll be more likely to get this. And yeah, following up on Rachel's question, is this for affordable housing only? Yes, it is. The income restrictions are based around AMI, and it varies slightly based on, the specific area. But in general, if it's a development that has a regulatory agreement with income restrictions, you would probably qualify. But yeah, you can talk to us later if you have additional questions on the qualifications. I put my email up there in the chat earlier, so yeah, feel free to shoot me an email, isharples@chpc.net. So
Just a point there, quick, Ian. Yes, Build is for affordable housing. There are other programs for new construction that are for market rate. So if you do have any questions or do want to get connected with other programs, we talk to them all the time. So please get connected with our team, with our program, and we could uh, refer you over to a particular other team or other program as needed.
yes, thank you, David. So let's see. Cool. So Jonathan Astman asked a question in the chat about how would bidirectional work in affordable housing? Would it only work with the chargers tied to the unit? Already answered that with one idea for using bidirectional in affordable housing is to actually tie into the house meter and pair with facilities EV. Is there anything you'd like to add on to that, Ari?
Um, No, I think that's kind of the answer. It may be more applicable to kind of a single family application. Build does cover single family as well. And that kicker is there. But yeah, we did have a project team that was looking at a bidirectional charger paired with a facilities EV, which was a kind of interesting kind of study for those days that were a little bit more overcast and PV wasn't enough to cover kind of essential loads, including that bidirectional charger with a facilities EV enabled the building to be designed to cover essential outage. So yeah, that's the answer there.
Yeah. Cool. See, Carol has some additional questions. I'll get those in a second. Just kind of going down the chat here. We have one for David from Lisa Hart. What do you mean when you say for electrical laundry, we're mostly talking about the dryer?
Oh yeah. I mean, when you're looking at washing, you're not really, or I guess for electric heating, specifically for the laundry, specifically for this program, we're going to be mostly talking about the dryers and disconnecting that gas line associated with the drying of the laundry. So that's kind of what we're talking about. That transition from the gas heating systems for the laundry over to electric heating system.
Cool. Then we have a comment from Brian Lane. Many nonprofit developers only use coils since they're easy to replace, a valid concern for affordable housing developers. They say the glass surface on the others often break and are hard to replace. Can you comment on new tech or the design of the appliances to mitigate a breakage issue?
No, I mean, I to be honest, I don't have a good response to that. It's just what I think part of the growing pains of this new technology. Um, but I think there's a way to start, even if you do have electric resistance in your home or in the properties. If you have the portable induction cooktops in the common area that can help folks sort of understand what induction cooking does, um, then it can then encourage folks in the future to move towards that direction. But yeah, I mean, when it comes to like from an asset management perspective, property management perspective, and whether it's negligence, whether it's or just kind of accidents or whatever it may be, yeah, it's an issue. It's glass, and I don't know off the top of my head sort of if there's an easy fix to be able to replace the glass or if it's a replacement of the entire equipment altogether. So yeah, long way of saying, Brian, yeah, I don't know.
Yeah, I have kind of anecdotally seen, trade shows or different publications that manufacturers are aware of this and are trying to find solutions. Some have touted, more resilient designs. So hopefully this is something that gets, sorted out as, like David mentioned, it's a new technology. It's emerging in the marketplace. So if that's, a barrier for people adopting it, it will hopefully get sorted out uh, by engineers in the future. Cool. And then Carol had two additional questions on kind of the program funding. Is there an increase in the $2 million cap per developer for those who have been participating? No, there was final guidelines issued last year by the California Energy Commission. The $2 million cap was not changed in that. Um, potentially legislation could change that. So if you want to talk to your legislators, feel free to do that. And then the second question was, how does the code change impact program funds or projects? I think that'd probably be an Ari question there.
Yeah, so, it doesn't impact the program in that the program itself is still here. We still do have those funds in Southern California. Code change is gonna shift the baseline as we have those projects that are under 2025 code. So the incentives may decrease slightly since the incentives are really based around how does an all-electric building stack up against the code compliant mixed fuel building. But there are still mixed fuel options under code, so there's still incentives available as we move forward into the new code.
Cool. Thank you, Ari.
Yeah.
And we're just about at time, but there are two questions in the Q&A chat that Ari was able to answer, so I want to make sure we get those verbally in the recording. The first one was, given that residential rates are only 32 cents to 41 cents per kilowatt hour. SoCal Edison tiered. Does $250 a kilowatt hour for battery seem like a program that is financially sustainable? Our answer that kilowatt hour battery sizing is referring to the sizing of the battery itself, so not how much it's outputting, which is rated for the amount of energy that the battery can store. So the incentive itself provides $250 per kilowatt hour to offset the upfront cost of the battery. For example, a single family home may need 10 to 30 kilowatt battery size. And then the second question was, isn't the concern with regards to health benefits regarding how something is being cooked, say heating oil above the smoke point, rather than purely the fuel heating source, and that ventilation is required regardless? Ari answered, gas cooking has been linked to asthma related to pollutants released in the combustion of gas. So yeah, it is like the gas itself is known to be hazardous, and that's because it is combustion, like anything that gets lit on fire, it releases things into the atmosphere. So I hope that answers all the questions. We're at time now, so I want to hand it back over to Christy. Thank you.
Thank you all. That was very informative, especially about the ovens. I had no idea that there was a difference. So I'd love to bring you guys back in 2026. And for all of you that have attended today, I will be following up with the slides and their contact information. So if you have any questions, you can contact me or any of us here, and we hope that you will join us again. So without further ado, anything else before I close the session? Cool. All right. Thank you all for joining, and we hope to see you again soon.
Thank you.
Thank you guys.
Thanks, everyone. Bye.